Welcome to the Tintri Intelligent Infrastructure Webcast. I'm Clay Ryder. In this webcast, we will explore how you can change your administrative experience by proactively using analytics provided by intelligent infrastructure for both offense and defense. Today, we will hear from a guest expert, offer some additional resources for your benefit, and have an open Q&A session at the end. If you'd like to ask your question during the presentation, please enter it into the Q&A or chat box at the bottom of your screen, and we'll queue it up for discussion later in the program. Without further delay, I would like to welcome our guest, Frank Shepard, to the webcast. Welcome, Frank.
Thank you, Clay.
And thank you for being here today. Please tell our audience a little bit about yourself.
Sure. I came up kind of through the admin side of things, the Windows and VMware side of things for about 15 years from run and build type roles. In 2010, I joined a regional cloud service provider and got to see really a front row seat for some of the issues around scale and complexity, especially when you're taking on what we would nickname sort of black box workloads. These are ones that our customers would send in via FTP or on a USB drive. There was a lot to unravel, a lot of performance issues going on a continuous basis. Around middle of 2013, I got to see Tintri for the first time, and cut to about 18 months later, moved over to Tintri to begin to share the message with just more companies.
All right, thank you. Let's move on. One challenge faced by data centers is understanding the state of IT infrastructure, especially if performance or service level impacts arise. Troubleshooting can often turn into a painstaking ordeal that crosses multiple disciplines within the organization, resulting in time-consuming efforts to find the root cause. Of course, there is also the requisite finger-pointing and issue deflection by the various constituencies. But even when things are meeting the needs of today, the question begs, what resources will be needed in the future, especially given the growing demand for IT to deliver more services to more users? Frank, how could a data center team get a good understanding of how well the infrastructure is functioning?
Well, in a nutshell, it's challenging. If you think about infrastructure, kind of like a warehouse. You know, today's traditional infrastructure, I kind of picture it like a giant warehouse or manufacturing facility. You've got pallets of data, information, gear, applications moving around and being stored inside of it, with forklifts driving them from A to B and moving them in and out, trucks loading and unloading, raw materials or data, and then shipping out finished goods or data on the other end. And a lot of times we're stuck with kind of poor telemetry. Those systems infrastructure today hasn't been designed to look inside the warehouse. So that, I mean, if you look at the warehouse from an IoT standpoint, this is why it's really important. You want to improve your manufacturing processes. You put sensors all over the inside of that warehouse, inside of that facility. And we don't have that from the infrastructure world today. So what that leads to is you're kind of stuck outside watching trucks come and go, and you're indirectly observing the efficiency of the facility, the efficiency of the infrastructure, but you're having to make a lot of inferences. You're having to kind of triangulate what problems are happening. So it really means that it makes finding out what happened, reacting to, defensively reacting to what happened, very tricky. It makes it almost impossible to know what's happening right now, and then it also makes it tough to say what will happen given some changes that we're planning. So it just means that it's tough to be conclusive about the diagnosis or the treatment in that construct.
Well, this sounds like double trouble in that we lack insight into both the root issue and how to go about fixing it. Now, Frank, we still face ever-increasing demands for IT services, even if in some respects we're operating in the dark. What are the common approaches to address this today, and what are the pros and cons?
Well, we have multiple platforms that we tend to layer on top of existing infrastructure. So SIM for event correlation is fantastic. I think of these like mortar in the environment. They're holding the bricks of your infrastructure all together. They're layered over the top of it, but they're still not gathering per VM or per vDisk or per database, per application information inside the infrastructure, the storage in this case where it sits. So we're looking at LUNs and volumes, great, but that doesn't really, no matter how granular the logging is from that, it doesn't tell us about the objects stored inside of it. We can respond sometimes with scripts and automation, but excuse me, one of the tough things about that is that very few shops have a exact one-to-one lab or test or dev QA environment for their infrastructure that looks just like production, much less behaves just like production. It's not as if production things are happening in that lab. So it limits what we can script or what we can automate from that standpoint. And then we have this burgeoning field of AI ops, which has a lot of promise to it. We're putting ML out in the cloud and taking all of this great telemetry, and we're doing, say, faster inference or faster triangulation of those problems. But again, it becomes a source data issue. So no matter how quickly you make a decision about a LUN, you're still making a decision about a LUN. No matter how quickly you respond and script to something that happens to a LUN, you haven't really actually put the controls and the visibility at the application level, at the database level, or the VM level. So the improvements we can make to speed and confidence in that case are somewhat limited. Not to mention the fact that we also get into incremental costs. So you just invested in your infrastructure, and to get it to speed up a little bit, to get a little bit an incremental improvement in confidence or visibility, we have to then add yet another cost to it. And then finally, it leaves us in a state where we're still somewhat on our heels. We're still not getting enough good, high quality, high resolution data to be able to be proactive in our approach very effectively.
I see. The standard infrastructure delivers a set of analytics providing a degree of insight into operations, but they're limited by constructs related to the storage itself as opposed to the workloads being supported. Yet I sense there is a need to think out of the box and reconsider the approach taken to solve the challenge at hand. What is a different approach to this challenge, and what could provide a different experience?
Well, the previous examples we used are enhanced visibility or actions outside of the storage infrastructure itself. It's outside of the infrastructure. So we sort of just talked about what always comes to mind for me is watching some real life crime show, and they say, see a crummy picture of a license plate, and they say, zoom in and enhance, and suddenly the thing is like high resolution. They can tell who the criminal is. And that simply can't exist. Like, that doesn't exist in the data center world. That doesn't exist in any case. If the resolution is poor, the data and the decisions made from it are going to be poor. So what we would call in the VM store, the Tintri side of the world, is intelligent infrastructure. This is saying we want to make sure that we get the right data at the right granularity for the right audience around the right time frame. So it really fundamentally can't be done without good source data. But when we're talking about intelligent infrastructure, what we mean is we want to take better sensors, put them inside the infrastructure. So now the IoT analogy comes back, and we've got sensors on the forklifts, sensors on the pallets, on the inventory. We're watching how efficiently things flow inside the infrastructure. We're also putting the intelligence inside the infrastructure. So now we've got a supervisor, a foreman who's watching models, who's creating patterns and watching patterns of individual databases or applications or VMs to say this is expected behavior based on past performance of these workloads. And then we also put the responsiveness and the automation. We bake that into the operating system running all of this. So now we can adapt at the right level as well. So we're no longer stuck outside the warehouse making inferences and triangulating what might be going on. We're actually inside watching. We're actually inside learning. We're actually inside responding. So What that means is if you start to look at it from a timeline perspective, is if you think about past history as defense, what just happened? What happened in our environment? We're able to see that down to a VDISC level. So now we can see what individual patterns of behavior were, anything anomalous that might have happened as well. And then we can adapt moving forward along that timeline. We can be incredibly responsive and adaptive in real time, providing automatic QoS and noisy neighbor protection in real time. So that means that let's say we onboard new VMs, we spin up a new dev environment, we spin up 100 more VDI seats. Those things are taken care of in real time. We adapt. We know what the existing workloads are going to need, how much we need to allocate for new workloads, and so we can build those, excuse me, very effectively in real time. And then moving along the timeline even further, when we talk about offense, we improve our offense by having this better data and this better telemetry. So we can say, well, what's going to happen near term over the next week? So the VM store can say, in the next 7 days, based on the capacity and performance demands of all the workloads supporting this compute cluster, these are placements of VMs that are optimal, and we can make those recommendations and even say this is what will be the outcome once we do that. So it's problem avoidance. It's not just quicker remediation to what happened. It's actually avoiding problems before they occur. And then long term, we need to go out. Ideally, at least one fiscal year. Sometimes we need to have a meeting in Q4 and say, these are the initiatives for next year. This is the mergers and acquisitions landscape for our company. This is the customer onboarding landscape, or this is the virtual desktop initiative that we're going to undertake next year. What's going to happen? What do we need from an infrastructure standpoint to support that? And what can we and can't we? Can we deploy 1,000 desktops in our current environment, or can it just be 500? So being able to move from what happened to what is happening to what will happen, and do that with the right level of granularity and do so confidently is really critical.
Well, in this scenario, we aren't focused solely on determining past issues with a limited degree of granularity, which to me, after all, seems to be a strictly defensive posture. With real-time predictive analytics, we're addressing immediate issues more effectively, but perhaps more importantly, we're eliminating future issues before they arise. How can intelligent infrastructure leverage analytics in a fundamentally different way to change the management equation in today's data center?
Well, I would say there's a couple aspects to this. And one, just from my own personal experience, my own days in operations, comes from just, troubleshooting performance with vendors. Something's slow. A user comes in and says, this is slow. There's seldom, an error message that's explicit, but someone can certainly raise their hand and go, this is slower than it was yesterday. So you would gather logs from a storage platform, probably a network platform, probably storage hardware, compute hardware, and probably even the hypervisor itself. Maybe even the application and the application owner get involved as well. So you've got all these different log files and performance data that you're going to ship off and open a ticket with every manufacturer. And those tickets are probably going to languish in a queue for 2 to 3 days, and then you're going to call them back and say, please escalate this. And so we would call them and escalate it. And then we would wait for them to come back and do their RCA. And a lot of times it would be inconclusive, or you'd have to sort of stitch them together and overlay them yourself. A lot of times those vendors would come back and say, well, it's definitely not us. It's probably the other guy. And lo and behold, you're sort of stuck where you were at the beginning. So the RCA, the root cause analysis for performance troubleshooting, becomes incredibly cumbersome and 9 times out of 10 fairly inconclusive. So in our case, as a cloud service provider, I mean, we had USB drives being shipped into the data center on a daily basis, or things being sent in electronically. And so a lot of times it was, do they play nicely with the workloads that are already running in our data center? We don't know. And so we get into these root cause analyses and they would be inconclusive. And so we would just end up moving workloads up to the fastest possible tier we had available. And we sort of nicknamed it the try it now tier. So we go back and we'd say, well, try it now. And then lo and behold, yay, we're in better shape. But we couldn't say why, or maybe it was because they weren't next to some other competing workload. It may not have had anything to do with the underlying medium. But if you're an enterprise or an SMB, you don't necessarily have tiers of storage. But if you're planning the environment, maybe you just say, well, this year we're getting the fastest darn thing we can because it creates plausible deniability when we have a 100-year high water mark of performance. Let's say you're building out VDI. You build out VDI for what happens between 8 and 8:30 a.m. That could be orders of magnitude more performance that you necessarily need for the rest of the day. Because of this better analytics to see exactly what workloads need to triangulate performance problems, diagnose exactly what they need, provide automatic QoS so that during 8 to 8:30, every VM and every user is going to have the experience that they are the first and only user on the array that day. And so being able to provide those things actually starts to come in and play a cost control role. We're saying don't buy and build for the spike, buy and build for the average, because we'll take care of those moments in time where things, those workloads are competing with each other.
Interesting. Intelligent infrastructure views a solution from a completely different perspective in that it's VM-centric as opposed to storage capacity-centric. And that would seem to better align with the unit in question, which is the virtual desktop or the virtual machine. How does intelligent infrastructure enable us to plan not only for the present, but for future needs and concerns as well?
Well, the analytics around intelligent infrastructure are obviously critical. As I mentioned before, one of the fundamental designs for intelligent infrastructures is providing the right information to the right people at the right granularity at the right time. So because forecasting is largely a data center exercise, it's a how are things doing in the rack? How are our investments doing? What investments do we need to make in the future? So it's more of a human or financial exercise. So we want to be able to answer questions like, what's the least amount of money I can spend, and what's the last possible second I can spend it? So the analytics power here is that it allows us to take the actual users, our customers' data, model their trends for up to 3 years in the past and up to 18 months in the future. So we're saying, here's your data, here's your environment with your apps. So your databases look like this, your VDI looks like Y. So in the case of customers, we have some customers who are now just cranking up VDI for the first time, from 0 to X hundreds of users right now. And so because of the telemetry we've been gathering over the last 10 plus years, we've got 13 trillion data points. And a lot of those are VDI related. So VDI in healthcare, VDI in finance. So we're able to not just take our customers' data and say, okay, as you define your databases, they look like this, or as you define your desktops, they look like that. We're able to say, well, if you've never done it before, here is what a workload like that will look like in your environment. So it helps us be proactive. It also helps us take those exercises that a lot of times take. Sometimes we've had customers say, I've spent 2 months, 3 months sending out an email called Doomsday Report to let my management and let our procurement team know that we are going to hit a ceiling for capacity, and that's a really, really bad thing in storage terms. So it's 2-3 hours every morning. I've got to run Excel. I've got to create graphs. I've got to send the email with an all caps subject line. And we're able to do that same exercise very clearly so that it's understandable by everyone in that conversation. We're going from technical to financial to business planning, and we're all able to bring everyone around the table, look at the same pane of glass, and within minutes make a really confident determination about this is our history. This is where we want to go. These are our needs, and these are the decisions we need to make in the near future.
Hey, thanks, Frank. Would you briefly share with us some real-life examples of how intelligent infrastructure has changed the delivery of IT services?
Sure. We have Dustin's team here just spending way less time on troubleshooting. We're, as I mentioned, the triangulation and the root cause and the logs and all that kind of stuff, and the multiple vendors and the finger pointing waste a ton of time, especially when you end up with no decision. And so the implication here is, as you reduce all this time, you're taking people, you're keeping them from having to switch contexts during the course of their day. They're able to spend more time focused on those innovative projects that you've hired them for. You hired them because they're smart technologists. Getting to the root cause of performance problems is a gigantic distraction, and it keeps those initiatives like bringing on M&A infrastructure, or launching new applications, or supporting DevOps. Those kinds of things get put to the wayside. So being able to reduce that time wrapped around the axle with troubleshooting those tickets, it reminds me of what a lot of our customers have said. Tintri is like adding a staff member. It's like adding more additional headcount, because you get a person's time back when you put intelligent infrastructure in your environment, and that's some incredible ROI.
Well, it sounds like this example experienced a different result from what he was accustomed to. What's another quick example of how Tintri's intelligent infrastructure has changed user expectations?
Well, I really, in this example, being able to use our analytics, and Dan's quote here is fantastic. And I really love his use of the term opaque. That's what we're talking about. We are talking about the warehouse again. No windows, no way to see inside what's going on. It really brings to mind what people often say, and it's almost cliche, but people would say, you can't fix what you can't measure. So in this case, Dan is able to resolve things because of this visibility. They're able to work in a fundamentally different way because of this level of visibility.
Well, thank you, Frank, for highlighting for our audience how intelligent infrastructure delivers a different analytical experience compared to standard infrastructure. For those who would like to learn more, what would you recommend?
Well, I would definitely say schedule a demo with one of our experts. I think that's the best way to see how all this works, and the different levels of granularity, the different level of analytic telemetry that we're grabbing, and what that does. From everything from what's happening, what happened, to what's going to happen. There's just no better way than just to see it live. I would also say check out our white papers, any of them based on what we can do from an analytics capability standpoint, just especially when it comes to forecasting, especially around how do I provision my data center, or build my data center, or what can I do in it with the current deployment, is really, really powerful. And then lastly, I would say we have written a lot on intelligent infrastructure in our blogs. My colleague Rob Gerard wrote a fantastic piece on intelligent infrastructure, a 2-part series. So I would say read that. It's worth getting to understand, and it will be really, really insightful.
Okay, Frank, our first question asks, can Tintri software run on other hardware?
We actually get this question quite a bit. It actually can't, because of some of the things I mentioned earlier. The fundamental design of the Tintri operating system is based on some work we've done with the hardware as well to optimize it and its response to what we're doing. So it is an all-in-one, hardware and software together.
Another question asks, can you provide some more detail around how to eliminate the finger pointing that you gave an example of a few minutes ago?
Sure. We have both the the analytics built into the platform itself that we showed that I showed just a quick screenshot of just a minute ago. That's real time what's happening with this virtual machine. Some of the other things that we've introduced recently is the ability to take, again, we're dealing with trillions of data points. We have every shop has somebody who's great at VMware or Hyper-V, working with hypervisors, but not everyone has access to everyone else's experience. So we have begun folding those configuration or optimization signatures into the Tintri analytics platform, so that we can say, given that we see latency in the host here, and you've got 16 virtual CPUs assigned to a web server, there's latency there, and it's a misconfiguration. It's over provisioned from a CPU standpoint. So there are other pieces of the environment that we can see because we're seeing all the way up through the hypervisor. Then at the scale that we're talking about from a data and learning and a fingerprinting or signature standpoint, we're also able to provide a lot more insight into best practices and configurations, so that we're taking everyone's experience and optimal knowledge and applying it at scale.
How long does it take to deploy a VM store?
I would say, in my experience over the last 5 years, an average, if you're working with a blunt knife to cut the tape, you might be 45 minutes. I would say incredibly conservatively, 60 minutes from cutting the tape on the box and putting it in the rack through being able to put virtual machines on it. It's incredibly fast.
Another question asks, and perhaps it's sort of a follow-up to that, does Tintri work with partners or service organizations?
We do. We have regional and national partners globally. So I would just encourage you to speak to your local Tintri team and or your preferred partner, whoever you happen to work with now. Just give them a call and ask them about how they can provide you with more information around Tintri.
All right. One person asked, can we send the links to the white paper? Actually, we will do you one better there. We will follow up with you with a copy of the slides, which also will include the link to the white paper and other resources. And when we send that to you, we'll also forward along replay information should you wish to share this webcast with your colleagues. Well, thank you all for your questions. Our time together is coming to a close. I'd like to thank today's guest, Frank Shepard, Principal Systems Engineer for Tintri.
Thanks, Clay.
As well as all of you in the audience for participating. Remember to check out the other resources that we've discussed, and if you have any further questions, please contact your local Tintri representative. Be sure to join us next time when Sean Myers will provide a deeper dive into SQL integrated storage, discussing how intelligent infrastructure can deliver unique value in supporting your databases. For all of us at Tintri, I'm Clay Ryder. Thanks for participating. I hope you found this time to be well spent.